welcome to OnePound channel. In my channel, I would like to play a lot of algorithm challenge. Not only for interview, but also I would like to play such like competitive programming, ACM, ICPC, Code Force, or Top Coder contest. I will practice a lot and share my idea or the process of understanding problem, figure out the solution to my channel. If you found anything wrong or you have a new solution, innovation want to share with me, welcome to correct me. I think that is also a way for us to learn together. And today I would like to focus on Leetcode problem 5152, which is n queens. Then you can find there the right bottom side there is a chessboard. Let's come to the Leetcode problem. So the first solution, I will not coding by hand because I would just share about my idea, and I think it will be very easy to understand. So for n queens puzzle, we would like to put several n queens on it, and each queens will not attack into each other. And here is the problem want us to return all possible solution, unique solution. So when I read to here, one thing come to my mind. I would use the first search to solve this problem. So in our result, we need to show what kind of position we would like to allocate our queens. So we need to know about queen row first. Okay, so if here is a 3-3 size chessboard, and I put my queen at the column 1 in the first row, and now I want you to say which position you cannot put the next queen. Oh, maybe I say I want you to understand the queens on which position will be attacked. The answer is this place, this place, this place, this place, this place, this place. So there is 6 place will be attacked. So why? Because first queen will attack any chase at the same column, any chase at the same row, any chase at the same slash, any chase at the same slash. Okay, so after you know the row of queen, I think this will be the first step for you to solve this problem. Okay, so I would like to create a diversity tree. And we assume that we are playing on 4-4 size chessboard, and at row 0 I will choose one seat to put my queen. Pay attention, you only can choose one seat at one row because queen can attack same row, anyone at the same row. Okay, so next row also have 4 choice. Four choice. So this is also mean we will choose column 1, column 3, column 1, column 3, column 0, and maybe you choose column 2. Okay, so the result for this example will be points. What is it? Points, queen, point, 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 queen, queen, point, 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 queen, point. Okay. This is our result. Okay. And we can check. Oh, this is lucky. We got a result because queen cannot attack anyone. This they cannot attack anyone. This is one of the answer. Okay, so I have already said that this way is very convenient. Not you don't need to check whether there will be conflict in the same row. So next, we need to check that whether each row will be conflict with the previous row. For example, this is row 0, row 1, and if I choose this play in row 0, then you cannot put when I get to row 1, I cannot choose this place. I cannot choose this place. I also cannot choose this place to put my queen, next queen. So we need to check. And if I come to row 2, I need to check whether it is same as the column of first row. This place cannot put my queen. This one is okay. This place also cannot put my queen, and this place cannot put my queen. So now we know at row 2 we can only put Q0. Okay, so that means that each time we get to the new row, we need to check we get to the new row, we need to check the previous old row. This is our thinking about first solution. Okay. So let's come to look at the code from the main functions of concise. If n is negative, then we need to return an empty result. Then we can call default search and start it. So here is my default search. In default search, which is so default search, before we check, before we choose we will iterate the whole column, and if column is valid for us to put our queen, we will push it into our sublist. If not, it will just continue to choose next column. Let me explain why sublist vector is type of integer. So here is column 1, column 0, column 1, column 2, column 3, and each row we will choose one number, which is column index. So our vector, our sublist is like column 1, column index 2, column index 3, column index 4, and the size is row size. And I can use this to construct my result, such like example for column 1. We already know that the index of Q, so we can put a lot of point and set specific index to Q, and each row I can complete. So this is very convenient. This is also one way to construct the results. Okay. And another thing I need to talk about is how we run about the check on our deficit tree. First, in the row 0 we choose the column 1, right? So it will come here, and come here, and then last one you can come here, second column. So now we are talking about backtrack, right? What is backtrack? After default search get to the deepest height, it will back to the previous state and try to explore the next answer. So now we backtrack and find if there is another possible solution on the same row, maybe this one, or it cannot. So this is backtrack. And when we call, so that is why we call DFS the operation between the fs need to be reversed after DFS, because what we talk about on here, you need to back to the previous state. Okay, so this is the concept of default search. So here, after I check the cities available, I can push the column index into sublist and call default search to the next row again. And after default search, just like I said, you need to pop back, go to the previous state. And if we also need to define the end condition for the default search, if size is same to n, which means that we already complete all choice, then we can push back the sublist which has already constructed to be string and return. So this is the first search part, and we can take a look at the validate function. How I check about validate. So we already know about the attacking role of queen. So here we can see that here I use if condition to check whether they are on the same column. If yes, then I will return false. This is not valid. How about this one? This one can check whether two trace is on the same slash. Okay. How? Let me draw something for you. How do we test that these two queen is on the slash? We can find that if they are on the same slash, the row difference will same as column difference, and or maybe such like these two, they also have the same difference between column and row. So this is how I use in my code. Row difference, absolution value of row difference will equal to column difference. If they are equal, then which means that two queens are on the same line, then return false. This is not valid. Okay, I will not take the detail into the construct because this is very easy if you understand why I use integer type of sublist. And another reason is that the next solution, I don't need to use construct function anymore. Okay, so next solution. Next solution on our Leetcode51, I will talk about the idea first. So if we put our queen at this place and 3 lines we cannot use, right? First is this line and this line and this line. Okay, so now we use the 3 array to maintain that, to record that whether there are trace take seat of the line, such like these are column index, these are an A index, and these are by index. Okay, so now index, because on this line there are some queen, so this will be true, and column index will be true, pi index will be true. So we use this to check that whether queen can be put on which place. So for example, when I come to row 1 and I want to check this place can be put my queen or not. So, and after calculation, I find that the line of this place is NAIDX. However, before we already on the row 0 we already make it true. So when we check whether IDX2 true, or you can also use false or true. True means seat is still available. Check NAIDX true. If not, and you can sit, you can put your queen. But if it is true, then you cannot sit there anymore, because if you sit there, queen will attacking each other. Okay, so this is the idea of the second solution, and let me check. Another thing is, how do we know the index 1, index 2, index 3? So for example, when we put our queen into the second column on the row, on the first row, then this means that column 1 will be true. So which means that this is column 0, column 1, column 2, and which means that the index can be calculated by the position you are at. So for example, if we want to calculate index 3, so for example, wait a second, I will draw it here. I forgot to change the. Okay, so I will say again, column 0, column 1, column 2, and for example, if you put Q at the second row on the first row, then column 1 would be set to true. Then how to calculate our index 2 and index 3 on pi array and non-array? So we will calculate pi array first. Look at the picture on the left bottom side. If we want to get the pi array and the index, we want to get the index which will pass through these two blocks. How can we get? The first one is this one. The third one is this one. We can calculate the index by our position. So first, this is 0, 0, 0, 1, 1, 0, 1, 1. Okay. So this is line 0, line 1, line 2. We can find that the index would be the row index. Plus column index. So if you choose this one, which is this one is 0, 1, so his index 3 will be equal to 1 because 1 plus 1 would be 1. And we will set pi 1 equal to true. And how about non array? Let's take a look. It will come from here. This is first, second, third. Okay, so this one is 0. Okay. Okay, so now in fact I can find that regularity of index is wait a second. The column at the bottom is mean that current column index. So let us check the column is 0 and row is it becomes 0. Okay, the first line has been get proved. Let us look to the next line. Column is 0, row is -2. It becomes 1. Okay, got true. So the index, now we know that the index of pi is row plus column, current column, and the index of NA array is equal to n-1 plus column index minus current row. Okay. Okay, so I think you already got all the knowledge which need to solve this problem. So let us start on this problem. If here is the exception handling. Of course, we need such variable. And same sublist at the same time, at the last time. Okay, so we also create 3 Boolean array here. First, same column array. Second, pi array. An array. Okay, so we can check whether each line is one queen in each line, and that we can calculate the index by our current position. Next, we will call depth search and return result. Okay, so we can come to create our depth search function. And current row number, pass our 3 vector This one is result. Okay, now we can start on it. For we will iterate the column on each row. So we will calculate if our column index is at one place, then we can calculate first I is index of pi. Second J is index of NA. If you want to check this place, however, someone on the same column or same pi line or same J line, same NA line, continue to the next choice. Now if we pass the choice, we find the available seat. Also set it to become true. Okay, so here I will call depth search after I finish current row. Next row, column pi NA sublist result. And you know I have talked about the reverse operation on depth search, so it will become false. And hop back. Okay, each time we will go to the next row, and for the depth recursion, we always need to be careful. We will always need to remember to define the end condition. So the end condition is that when the row is +1 again and again, then when row is out of limit, you can okay, I use this to make. Okay, so here is what I will talk about reserve function later. So why I use reserve here? This is vector. Although it is a dynamic array, it can again and again and again dynamically allocate and bigger the result. But in fact, when you find that the size is not enough, you will just double the size, even though I just want to add one element. So this is not very efficient. So what I see in the effective C++, the father of C++, recommend that before we try to use pushback, we should use reserve to make size bigger. And then pushback. So this is why I use reserve first. Okay. So now the last thing is construct function. So construct Okay, I think this is all. Let me check about it. Oh wait, I forgot to pass. Okay, it seems that the answer is right. Let me submit. Okay. Right solution. However, only faster than 36%. In fact, this is still, even though we use new solution that with 3 array, however, we still need to iterate all position, all column. So here I even need to use construct to construct a new result. So after I read the discussion board, I have find a new way to construct the result in this problem. So you don't need result, you just need a new sublist. String. Okay. We don't need construct anymore. String. String. Okay. So now we need to initialize it like and n rows, and each line is consists of string that have n points. Okay. So now we have already n point, and I choose the position means that place I will put queen. So it means that at row I will put queen, which is pos equal to set to q, and also here we also need to reverse the operation to back to become plus. So okay, this is the way to the way without construct. Let me take a test case. Okay, and try again. Okay, so it seems that doesn't influence a lot. It's still only faster than 39.94% of commission. Okay. However, there is a way can still be faster, be efficient than current way, which is called Bitwise Trick. So why Bitwise Trick will be efficient than current solution? Okay, so we need to know that when we would like to handle this simple calculation, but in computer it will convert to bits first and plus and get answer and give back to you. So if we just wait a second. If we use directly operation on bits, it will be very efficient and faster than we use decimal or even Boolean type, because we will reduce the time on converting bit from type to assembly type. So now in the new solution, I will use Bitwise Trick that change the vector boolean to bit array, which is int, and we will do such like operation on it, and that would be very faster. Okay. So from now on, I will start to introduce many tricks related to Bitwise Trick to solve this problem. If you have any problem or very confused about Bitwise Trick, you can go to look at my another video. I will take it to solve some of the Bitwise Trick problems on the Leetcode. So I will also put the video link on the video description. So what is our idea? First, column will be 0. pi will also be 0, null will also be 0. They are not vector anymore. And so 0 means that it is still available seat to take. However, if 1 means that not available seat. So for example, we already know how to calculate the index, right? And again, we iterate all column, and so we want to see whether or will there someone be at the place will be if it is 1, then we will continue because the seat is already not available. If not, we can choose that seat. Oh, so sorry. This is we already know that this is integer. So this is become the post bit of column row plus post bit of pi. Bit of NA, and we want to read the bit, whether the bit is 1 or 0. Here's a trick. For example, if there is int integer and I want to read ith bit, I can just use this way. Or not, you just need to A and right shift I and I. Oh no, and 1. Why? So for example, this is A and 0, 0, 0, 1, 0, 0, and 0, 1, 0, and this is I bit, and I got AND operation on it. So how do I test? I would like to do operator of AND with 1 to check whether it is 1. If it is also 1, 1 and 1 would be 1. However, if 0 and 1, it would be 0. So I can right shift it to the last to the rightmost bit, and all the previous bit will be 0 because they are already 1 0 here. And now we can test whether it is 1 or 0. Okay, so this is one trick to read the bit, specific bit. Okay, so another knowledge about the how can we take a seed, just like here we use at the row at the position become a cube, which means that we take a seat. And how does it work in this example? So wait a second. For example, okay, so this is column, and if I take the pause set, which means that the pause bit will become 1. Okay, so how can we make the pause bit become 1? We just need to reverse the bit. Originally it is 0 and it become 1. So reverse the bit. I would like to use XOR operator. So here I would use XOR with, I think, okay, this way I can get column with take a seat, and you may think why I use this method to reverse the bit on the pause bit position. So first it would just column, and 1 is just like 1, and this is 0, and this is at the pause bit. Okay, so first I need to make this 1 also come to this place. So you need to left shift pause bit to become here. Okay, so when 0x or 1, they are different, so it will just become 1, which means that this seed is already be take. Okay, So this is how we take a seat. And after the first search, you just need to XOR again, and it will back to the previous state, which is just like reverse and reverse. Okay. Okay, so this is all we need to know about for the solution. So let's come to write a new code. I would like to directly change from this place. Okay, so here I need to change it. Okay. I think here I don't need to change it, and now I need to change type. Column pine and a vector string. I don't think I need to change it. Result done, and this one sublist for. Okay, so now here I think I need to change. So this will become because I want to read the bit at the position. Okay, and we can OR it to combine three things together, and after combine we can end with E to know the value with the value of it. Okay, so if it is not equal to 0, which means it is 1. It is 1. So means that the seat already be taken. That is not a valuable seat. Okay. So now I would change just like I say, reverse the bit. Oh, wait a second. Okay. Hmm. Again, the first search, and again reverse the bit, then it will become the previous state. Okay, I think this is all I need to change. Let me test it. Great. And 5. Okay. Let me check one thing. Pick sublist. Oh, what? It is very interesting. I think this is a problem that we need to check. That if I use reserve, it would take a lot of time complexity. Okay. So maybe I should take a note. Reserve takes a lot of time. Okay. However, do you think this is all? These are all solutions? What I want to tell you is not yet. Till now, we always iterate through the whole columns. In fact, we don't need to iterate through the whole columns and check it conflict or not. We can just enumerate the available seats. This will enhance the efficiency. Of course, it makes sense because we don't need to iterate through the whole columns anymore. So what is the idea? Okay, let me check. Okay, so before uh, I introduce the most efficient solution for this n queens challenge. I would like to correct something that I have mistake previously. I say that vector reserve will takes a lot of time. In fact, that is wrong because I write at that time I write I think we can see the code in history. Let me find which one. Not this one. Okay, this one. Here I call result reserve again, and I say that this take a lot of time, right? In fact, that is wrong. It doesn't take so much time. It is only linear time, that how much you want of the size, then it will allocate in the memory for you. So for example, if so if you just reserve 5 and you call pushback, maybe I'll give a less than pushback 1 vec pushback 2. And when you want to do the pushback again now, then vector will go to request for the double memory. So the reserve is for us to give make a request and allocate the memory in it, and it will just call more memory when the request memory has been used off. So when we call pushback again, then compiler will go to allocate memory. So to avoid the problem of space complexity and garbage memory, we need to make sure that we call reserve of the size before pushback instead of just calling pushback. This is the most important what is say in effective C++. So one more example. If I write 1 and I call reserve 2, then what do you think the content in current vector memory? Okay, the answer is 1 0 0. Now you will know what I mean. When vector want to push back and it put 1, and after vector will request 2 of memory and initialize it with the value of 0. Okay, so this is what I want to say. Okay, so now we can come back to today what I want to say, the most efficient solution. We don't need to iterate through the whole seed and check it again and again and again whether it is available seed, valid seed or not. We can just enumerate the available seed. This will enhance a lot of time complexity. So, I will start from the today's new ideas. Okay. Okay. Today a new idea. So first we already have, I think you still remember that we have three integer, right? Column, pi, and none. So for column, it will record the column on the queen on the same column, and pi will record such slash, and none will record such slash. Okay. Okay. So first one means available. So we initialize column to be 0, pi to be 0, none to be 0. However, we want 1 to be the available seed. What we need to do? We will need to make a 32-bit integer and make it just show the lowest n bit, which is used to show n queens place. Okay, so which is used to show, yeah. Okay, so how do we do that? This is the trick. For example, this is original number for 32 bits, and we want the number. We use the number 1 left shoot n for n bit and minus 1. What this will become? This will become 1, and here is n bits. And when we try to minus 1, it would become 11110, right? So if we try to make this thing to end with our n bit, what will it become? For 0 of n bit and 0, 1, 1, 1.
and so here will be a bit of 0, right? Okay, so this is how we can get the lowest n bit of data. Why? I think this is still very hard to understand. So this is because I will rewrite it again. When you left shift n, it will become 0, 0, 1, 1, 1, 1, 1 for n bit, right? Okay, and what we want is lower n bit. So lower n bit for lower n bit, and we take it, and here the first O minus n bit by AND operator must become 0 because here are all 0. So now we don't need to care about here because they should be 0. But what here? Some of them can be 0, some of them can be 1. That 0 means you can choose. 0 means you can choose this. You can choose this seat. 1. No. 0 means that you cannot choose this seat, but 1 means that you can choose this seat. So the result by the end will become, if you cannot choose this seat, and the result is 0. You still cannot choose this seat. And if you can choose this seat and end with 1, you still can choose with seat. So you can store the result of the column pi and an eighth array by this way, and the first O minus n bit must be 0. So we don't need to care about it anymore. Okay. Let me clean a board. So if we want to get the available seat, then this is the equation. Okay, I think I have already explained here. The purpose of this line is to make our result can be compressed into the lowest n bits, and the first bit will all become only 0, and we don't need to care it anymore. But one thing we still need to care about it. So you must be confused now why I need to reverse I need to make the complement bit of these three. Why I need to make complement number of our result. So I have said that this is just for convenience for our definition. We want 1 to be available seat, 0 to be unavailable seat. However, we can only initialize pi zeta to be 0. However, 0 just mean the seats are unavailable. So if we still use 0 to be initial result, we will not able to choose any seat forever. So we need to make it become 1 1 1 1 1 by this. Okay, so now we know how to store and compress our result in lowest n bit. Okay, so next, okay, next what we want to get is how we can enumerate only the available seat. Only enumerate available seat. So I will give some example. I will take 8-bit A queens for example. If we have 10011001 for our example here, and we want to get the only seat we can take for queens is only 4, right? This one, this one, this one, this one, and we will take the seat from the following the order from right to left. So how can we get the first seat? The way is I will make this as A. The way is A and minus A. How does this mean? I will calculate it for you, and you will finally understand why this can work for choosing the rightmost seat. For if we want to get minus A, we will need to get the complement number for it first. So reverse each of the number. Zero, 1100, 110, and plus 1, 011001111. So this is his first. This is his minus number. 011001111, and let us make an AND operator. It will become 1001110 1000000. Okay, so this means that we only uh, store the rightmost one, right? This is very interesting that we can use such kind of bitwise trick to make a magic like this. We can use this to get the rightmost trick, rightmost magic, rightmost one. Okay, so then after we find the rightmost one, we can use our available to XOR with it. Okay, so then we can get 1001100. Okay, so it becomes 0. So we use XOR operator to mean that we already take the seat. So now this is our new A. And next time we want to take the second one, right? So again, we just need to get minus A again. 000. Oh, sorry. 1100111 and make an AND. It will become 000. Oh, we still cannot do this. Sorry. Because when next time our pi, why we cannot do this at the next time? Why it is strange, right? Because when we come to the, we can look at this picture. Pi is from this side, and A is from this side, and column is from this side, right? When we go to the next row, column won't shift. However, if you choose this one, and when pi go to, this is pi, and when pi go to the next row, it will become at this position. And now is this side, right? So if we look at the example of now, if I choose this position at the second position at the first row, and by the now it will left shift for one position. For pi, it will right shift for one bit, and column will stay at the same way. So we cannot calculate like this. We will need to shift first and calculate the A again. We need to shift when we go to the next row and calculate the A again and use this trick again to get the rightmost one. And now the rightmost one would be the second one, and we choose it for our second seat. Okay, so now I have explained the detail of the algorithm, so I will make a conclusion again. Okay, so first we would like to store our column pi not at the lowest n bit, so and also all of them need to be 1, so it would become n bit and 1 1 1 1 1 1 0 0 0 0 0. Okay, so this is our first initial status. Okay, second we need to make sure whether there is a available seat. In the process, it will become such like 1 0 1 0 0 1 1 0 or whatever. Some of them are 0, some of them are 1, and we only can pick the bit 1 to place our queen. And so how to pick only the bit 1? We can use the a and minus a to pick the rightmost one and reverse it, and reverse the bit, which means that we pick the seat. We sit on the seat, and this is pick the seat. Okay. So let me think whether there is something core concept I need to talk about this efficient solution. Okay. So the last thing, we need to construct our result y, right? Here we need to construct it to be a string. But how? So let me show how to do it. Such like okay, so this is why we need to use p. Okay, so first, if you just want to reverse 1 bit, in fact you just need to For example, you just want to reverse the rightmost bit 1. Okay, we can do this. For example, 0 1 0 0 1 1 0 1. We want to reverse this bit, so we can try to minus 1, which is 0 0 1 1 0 0 1 1, and we use AND. It will become 0 1 0 0 1 1 0 0. So if we just want to reverse the rightmost bit 1, we can just use A and A minus 1. And why should we first pick up the P, which is the rightmost 1, and then reverse? Why we need to separate it two step, but not just combine it to A and A minus 1? Because the reason is that we need to construct our result. So if we want to construct our result, we need to show the seed we pick. And the way we show the seed we pick, for example, by this way, for example, we pick this seed, right? And we want to show that we pick this seed. It will become in this way. P will become right. So this means that we pick this seed, and we can use this to construct our result, because we know which position we place our queen. Okay, so in fact, this is so there is still something we need to care about. This is from right to left. However, in fact, in our array, this is from left to right. So the index is different because the order, such like if we choose this seed, this means that we not choose the rightmost seed. This is wrong. This means that we choose the leftmost seed. However, this is very easy to calculate, because we just need to maybe use a -1 to a -1 to minus this index in a bit. Then we can get which column we picked for our queen. And so how do I get the index of the bit 1 in this P? So we already know that there must be only one bit of 1 in our P, because each time we only choose 1 of the seed. Only one other must be 0. So it must be the power of 2. So we can use log p of 2 to get uh, the index of this bit 1, right? So such like this one, the number is 1, which means this is 0. Okay, so 0 means that okay, so this is 0, and we just need to use -1 to -0, which is because why this is a -1, because they are from index 0 to 7, so we need to make 8 -1 and -0. Then we can get that we choose the seed at 7. So I think I make a wrong explanation that this seed is also mean I choose at the rightmost seed, and if I choose this seed, it also means that I choose at the leftmost seed. Okay. So I think this is all we need to figure out before rewriting a solution. Okay. Now let us try to write the solution. So okay, so first we still need sublist, and this sublist will store the queen in a row. So there are n place and there are n row, and each of them have n point, a dot. Okay, because there are n sides of chessboard, and we also need a final result. Okay, so here make a exception handling. Push back and return the result. Here we need our column by and also the default search function, and then return our result. Okay, and here is our default search function, void default search. Okay, so parameter will be n, and row column by a vector string of sub is vector string of result. Okay. So then what I say is compress the column by an A important information in the lowest n bits. That will convenient for us to operate it. So this way, and column by now. Okay, so this is for us to make our zero value become 1. For that we can choose the available seat. While available not be 0 means that there are still the seat we can pick. We can pick the rightmost seat. Okay, and take a seat, place our queen, reverse the bit, and then so reverse F. We know that we already take the seat, so we need to store we can store in our sublist. First, get our column index. Okay, and store it at our column index. And if row equal to -1, which means that we already come to our last row, then we can put our result into our sublist into result. And okay, then return. If we are still not arrive at the last row, we will call defer search. Okay, this means that you can see that we only take the seat for our sublist, but our column pi NA should also make a change that show that they also have taken a seat, so they reverse the seat at P. and for pi reverse p. And because for our pi array, each time it will just right shift for 1 bit. So we need to right shift for 1 bit when it go to the next row. And for our na, take the seat and left shift for 1 bit. And then this is sublist and the result. Also, okay, so another thing I have talked about is this is backtrack, right? So it will go to the most deepest row at the first time, and then it will pop out one result and try a next result. Okay, I will show again. I will show again. So I assume that here is the last row. So for default search, it will go to the last row, and then it will pop out this result, pop out this choice, and go to try next possible seat. So this is called backtrack. So this means that we need to reverse the operation before we call default search. Oh, so first we need to here. Okay. So I think it is all. Let us. Oh, here I still not pass the parameters, so it would be 0 column by sublist result and run the code. Let me see. Where do I make the mistake? Row at column index q. Row equal to sublist and row +1 column b by p, right shift, left shift, result. this one. Okay. What? Wait me for a second. Okay, okay, okay. Oh my god. Oh, I got it. These things. Okay. So I think here is the problem. I can check it again. Let us check it again. Okay, so this is int, and for log 2p is 0. Okay. Right. So what I explained in the previous step is right. That if I choose this place, it means that I choose the first column. If I choose this bit, it means that I choose this one, choose this one, choose this one. And so if P is like this, and this would become 1, and it means that I choose this side. So wait, oh, sorry. So we don't need to use a minus 1 to minus our result. We can just only get the result from here, log 2p. That is why I'm wrong here. Okay, let me test other result. Oh, I think okay. So I think my solution will be okay. Let me submit. Okay. So here we got 0, right, and faster than 100% of submission. Okay, this is the most efficient solution I get from this challenge. Okay. So here we can find that this challenge need Bitwise Trick. So maybe several days later, I will also give a video about the Leetcode challenge on Bitwise Trick, and you can subscribe to my YouTube channel, then you can see such kind of video. And subscribe me or correct me if you find something about my today's YouTube channel or something you might like to share with me. Okay, so thanks for saying goodbye.